Hey, Mars Framens here. As you all know, I've been working on my side project, which is co-op procedurally generated ocean explore game. And since majority of the time players gonna spend in the water or ocean, exploring underwater and just jumping from one island to the other one, water is probably the most important aspect in the whole game. So there are few key elements that I needed to have in my water system. So obviously building your own water system is tough, so I probably went through the majority of options on the marketplace, and they either are made just for the single player use only, or they comes with a bunch of stuff that only devs know how to use. And unfortunately most of these expensive plugins comes with a really short support life, and at the end you're left with a broken plugin that only devs know how to fix because they are lacking documentation or they're just commented really badly that you have no idea what's happening there. So going through all these options, then I kind of decided, hey, I'm gonna build myself my own water system. At least I'm gonna know inside out how it works and I can customize how I want. And so when building a water system, there's kind of like three approaches how you can build it. There's like three water systems how you build, and it's not, you don't need to pick and choose one. A lot of games combine them. Like for example, I believe, at least from what I have seen visually, for example, a game, Sea of Thieves, I believe uses all three of them to just make their water system so amazing and so diverse. So the first one is the classic shader based. It's like just water material, shader based. It's very good for flat waters. AAA games still use in scenarios where really your water has basically not much of a use. And then there is like two other options, and the most advanced is called FFT. It's very complex calculations, and really there's some plugins in the marketplace use FFT waves. You can get really nice cinematic waves and it looks really, really realistic, but again, it comes with a downside. It's kind of like, performance heavy. And the other thing is, since it's complex calculation, then it becomes very hard to develop a buoyancy system for that, which is again, very important for me is like network replicated buoyancy system. So I can swim, I can have boats and all that works. And that leads kind of like to the middle system. It's called Gerstner waves. It's also calculation based. It's actually not so hard. There's a bunch of resources. There's some YouTube channels that explain Gerstner waves very well. This is not going to be a tutorial. I'm just going to go kind of like overview of what you as a single dev actually can achieve. And I think for my personal project, it works great. So when I was building my system, first kind of like the goal was water system needed to be dynamic. Usually what's the issue with a lot of these water systems is it kind of like supports one global water parameter. And for me, it's like, since it's co-op game and I want to make it like more realistic, I want in some parts, let's say you have storms, some parts you can have sunny weather and all that. So you're not like, hey, if it rains in one place, it's going to rain everywhere and the wave's going to be big. So what I did was, the challenge was to adjust so the buoyancy and the shader and everything else in post-process is dynamic. So we can see here where, for example, going to be islands, the water is going to be flatter. As we're going to go more away, as we are going more away from the island, the water is going to start to pick up and we're going to start to get ocean waves. So we can see the waves are getting bigger and we can swim, and it automatically our buoyancy is adapting, and also our post-process, you can see it's still no issue, the same thing as it was in flatter water. And then we can see also we have storm waves. And for just demonstration, I exaggerated them so we can just make sure and see that we have huge waves. In my game, it's not going to be. These waves are a bit too big. We can see there's some clipping issue right now because they are just too big. I could just raise actually the limits and they wouldn't clip. But in my game, we're not going to have this kind of big waves. But as we can see, if we are going closer to these storm waves, again, our buoyancy is adapting, our post-process is adapting and everything. Buoyancy probably can glitch out a bit here because it's not meant for this kind of waves, but it's actually, yeah, you can see it's lost a bit, the waves, but we can see it's actually doing pretty good job. And so we can see I have parameters in my actor, which is basically I can set if it's ocean or it's a shore. So depending from that, we're gonna have this flat, let's say center, but I can adjust the location where I want it. We can see here is the same thing. We have a flatter. We can see actually the effect here. If we, for example, come here, play from here, we can see the big wave comes, and the closer it gets, it just flattens out. It's scale based, so I can scale it. So 1 is basically the baseline. So I have baseline waves, which is ocean waves, and then I scale from that. The storm, again, gonna multiply regular ocean wave, and for the shore, it's gonna decrease. So for example, here I'm just multiplying by 0.1. So it's just 10% of the ocean wave. And again, I can just adjust it how big I want. I can even make it bigger. That's something I'm doing actually. In a second, I can talk about more lakes, but you can see I do opposite in a lake. For the lakes, the outside is flattened, so we don't have waves, and then as deeper you go in the lake, they are starting to form some waves. We can again put it here, and we can see actually cool thing about the storm is it's forming. It's not like it becomes right away, and it's cool because you can integrate this. I integrate my game with Alter Dynamic Sky. They have storm features, so basically the storm forms, and I can match my storm actor with it, so it storms the waves. And then I can just move the storm anywhere I want, and it's just gonna make a storm there. And cool thing about the Gerstner shader is, since I have built my own, is I can have different kind of water looks. So here for the demo, out for testing, obviously I had this one. Then this is like kind of like the main water that I'm gonna have. And then I can create different things. For example, like since I'm gonna have different theme islands, for example, I'm gonna have low poly island, we're just gonna be like low poly actors. I can apply this kind of low poly water, and it works as the same as this kind of cool water and this one, and they have like a seamless transition, so I can be able to transition from different kind of levels, and I really can make my game pretty cool with different style of the waters. So that was kind of like the first thing, and again, as I said, everything is network replicated. It has a time sync. Everything is actually what I have built is actually configurable. So if I open up my base character, they go to my water component. I have a ton of water settings. So actually I have like a client prediction inside. Server has authority, but I have inside client prediction to just smooth it out a bit. So in case if there's a net lag, use dynamic prediction. So what I build is, so there's a prediction lag. So basically the smaller the lag, the less we're using any kind of client prediction fixing. So for example, if there's like no lag, you're playing locally, then we're practically not going to use client prediction at all. We're just going to fully rely on the server. If we are getting more lag, then we're going to kind of like the client prediction and client adjustments going to get a bit stronger to visualize, and so it's not like jumping and all that rubber banding. So that was kind of like the first thing. Once I nailed the first core thing, like making my system dynamic, making post-processing that it follows, I wanted to start to level things up, and I created a lake. And because I want to create some islands that there's a lake, or it shouldn't be even just a lake, it could be underwater caves where you're swimming. And so I kind of introduced the priority system. We can see the priorities. So ocean's always going to have priority 0. But for example, if I enter the lake, it has a higher priority, so it's going to take it over. So if we, for example, go play here, right, we can go in our water. We can see our post-processing is working. We can swim up and down and all that. And then if we go into the lake, once we enter the lake, it takes over the swimming and post-processing and everything else, and we can see it's actually, and we can swim now in a lake seamlessly. And again, if we enter, again, since we entered, it switches to the next priority, searches for whatever volume you are in. So that's why I can create like priority 2, 3, 4, 5, and we are kind of back in the ocean. So that was already number 2 thing that I solved. And then so next thing is, okay, we have these oceans and that. Now we need to start to work on exclusion volumes, because there's going to be, again, underwater caves or some kind of like ships or boats or under the water, whatever. I'm going to need areas where, you know, you're not swimming. But so I created these exclusion volumes. So I can go in here, and we can see actually in exclusion volume, you don't have post-process effect. If you exit, we have it. And then I can have this kind of post-pro, again, like exclusion volumes, where I enter and I exit, enter and exit, and we can see it actually works pretty good. And I can have, like, you know, water, underwater tunnels and other cool stuff. And biggest challenge in this was actually not making exclusion in these transitions. That took like a day or two, or like really nail it. All the scenarios where I'm switching and making sure that it replicates nicely and all that. But actually the biggest challenge was post-processing, because how usually, like, there's detecting the camera movement, it's actually very tricky. So usually how other effects work is your character enters. So now I would have, like, say, no post-process, or it switched to something, but it would look stupid because my character would just sit now at ground, and it would not look realistic that I'm entering volume and exiting. And only volume that actually tracks well the camera and entering and exiting is post-process volume. So I searched the code for of the post-process mesh. So I dissected it, and I figure out how Epic is you doing that in their code. It's actually kind of like tracking every frame for the camera. But again, not every exclusion volume I gonna need this effect. If I ever gonna need it, I wanted to implement it just to make sure I have this feature. If, for example, I'm really gonna use something like this, mostly, like, you know, in my project, I want to make sure that it transfers. And we can see it seamlessly just transfers. If we go in, it just goes to the post-process underwater effect, and if we go back, it's nothing. It's modular. It doesn't mean that I'm just turning it off. I can actually switch from one post-process effect to the other one. So if I go here and I can just implement something else, let's say here it's like darker, or, you know, some kind of overlay, stuff like that, I could just switch them. It's just, it detects the transition, and that's pretty kind of cool. So once I nailed that, the next thing was working in the caves, because water caves and some kind of like ships where I enter and all that, it's going to be very useful, and I'm probably going to really work on that a lot. We can see actually water works well. It detects collisions and everything else, so we are not like swimming up and all that. So, and then I have like a cave demo here. So if I go into my water cave, we can see I can exit. So while we are even under the water, we can see like we're actually under the water. So again, no post-process effects. We can jump and all that, and then we enter. The cool thing is we are taking advantage again of that priority thing, and I have set actually priority not only between the waters, but I have actually, if we find my exclusion volumes, I have set up for exclusion volumes also to respect the priority. So if I said, like, you know, this is the max int, then it basically, that volume forbidden for swimming from all the volumes, you know, whatever it overlaps. But I can also set, for example, this exclusion volume number 5, I have said that the minimum priority is 1. So if it's 0, it blocks swimming. So if it's 1, then it lets me swim inside this exclusion volume. and we can see transitions. And if I exit, oh, and also a cool thing is the water, there's a gradient. So if we can see, the higher we go, the lighter the water is. We can see it's nice blue. I still need to adjust the tones. And then, for example, if we go more down, we can see the water gets darker and darker. So, and I also have this buoyant boat. So if I enter, I can press play and we can go and we can stop. We can see how it works also over the network. I can go as a client, I press the button and now we are moving. No issues, and again we can see that in a second the buoyancy works as it should. No weird jittering or anything like that. And we can see even in going in like weirder storms, it actually does pretty good job. So there's like, you know, calculation complexity. So this is like a first level that enables that in a far distance. So for example, you have a ship in a distance and you're getting closer to that ship. You want, like, you know, at least to start the move. So this is the first layer that activates like a simple buoyancy calculation, which is actually very performant and very, very light. And then if you enter this second box, then we are using full blast buoyancy calculation, which is like really, really like accurate. So that's why, like, if you have like multiple objects in the distance, they don't need to have high loop, high iteration calculations. We could use simple buoyancy calculation, so object just moves, and I can just show you how it looks in a second. So for example, we are going to the boat. We're gonna see that actually when you're far, then the boat completely stops. Let's activate the boat. Let's go with the boat. Now we can see it's going. It's going as itself. Then in some moment it's gonna switch. I don't know if it's gonna be really noticeable here, just the switch. And now when it's far enough, when we are out of that far distance, then the buoyancy completely stops. So it's not anymore simulating buoyancy, because we don't want object to be like, you know, objects that are very, very far, we don't even see them, to be buoyant. And then if we come back, you know, we can see again our boat is buoyant, and if we are going farther away, then the buoyancy, again, simulation can stop. So this is kind of like a showcase of my water system that they're building for my project. As I said, there's going to be some more effects that I want to implement into this. As I said, I need to get like some soundtracks, sound effects, and I need to make also, like, you know, if you're going under the water, holding your breath and all that. And that's going to be part of actually the gas integration. If you guys actually are interested, I can pack it up, and if you want to test the water system, let me know, because that would actually be cool to get more feedback and see if you can break something. Because sometimes it's very hard to test things that you know how they're supposed to work. It's easier to give somebody who has no idea, and then they find different kind of bugs that we can test. So let me know, guys, if you want to test out my water system. I can totally pack it, make it the world a bit bigger, procedurally spawn, and you can just walk around and explore the water. But yeah, this is my water system. It took quite some time to build it, and I think it was worth it. At least, you know, save some money, no headache that it's gonna become one day end of life, and I'm gonna need to build then from the scratch. So I have really something that I can just use in the future. So thanks for watching, guys. I hope you enjoyed this video, and see you in the next one. Bye.